Hello, hello, hello. I'm Warren Redlick. I'm here with John Gibbs, aka Dr. Know-It-All, one of my favorite YouTubers. I'm wearing the Turn Impossible into Late t-shirt you can buy at elonbits.com. Please check out John's channel, look at his merch. I think he's got a really cool water bottle
Oh
that he's
yeah,
showing off.
I can go. First of all, hello. It's nice to see, but might as well pitch that. Yeah, there's like 4 or 5 different varieties of this now, the Cybertruck. So for if you've got a Cybertruck on order, you can get a Cybertruck now
That's
while
right.
you're waiting for the real one.
And I've got the Tesla stainless steel water bottle also at
Nice.
elonbits.com. So
Hey, it's hot. It's summertime. We need water, so we got to hydrate. So there you go.
we're going to talk about Dojo. We're going to talk about full self-driving. We're going to talk about how Dojo and the increase in computing power affects what we're seeing with FSD beta. I didn't mention it to John beforehand, but we may talk about how this relates to Optimus and the bot. We'll see where this goes. We're going to keep going until we run out of stuff to talk about, or until John tells me he's got to go. So for starters, John, there was a graphic that was released by Tesla's AI team showing the increase in computing power. And I think you said you may have it up on the screen.
So yeah, this is something that is a pretty impressive graphic right here. So we are at the start of Dojo production in July 2023. This was from Tesla AI, by the way. This is about as official as it gets. This is not something that some third person, I didn't generate this graph, but you can see we're way down there in terms of numbers of A100 GPUs, which I thought was a funny way of measuring things. But that would be the NVIDIA A100 GPU is kind of a standard in machine learning server racks. And so you can see down there, I don't even know what the number is. It's got to be maybe 10,000.
No, I think they told us at an event that they had 15,000 GPUs.
Right. So somewhere right around there. It's very, very small, but they're looking at the start of next year of getting into the top 5 in the entire world up to about 100,000 equivalent, and then getting up to somewhere around 300,000 equivalent by, let's just call it the end of 2024. So the 18-month window, they're going to go up from, let's say, 15,000. So what is that, 20x, something like that. So their compute power is going to go up by a huge amount.
Right. And even by the end of this, even by early next year, we're talking about the compute going up by 6x.
Yeah, exactly. So we're looking at really big numbers and incredibly impressive, like ambitious growth. And I think we should
note that the graph is rising at the end. It's not like it's going to level off at 300,000 A100 GPUs or 100 exaflops. It looks like they're heading for 200 exaflops, 1,000 exaflops, and so on.
Yeah, and the question becomes, why would they need this, right? I think that's what people would generally say, is they would say like, well, don't they have enough compute power right now? I think the obvious answer to that is, have you ever felt like you've had enough compute power in your life? If you do any kind of compute, yeah, right. It's like whatever you have, you just sort of fill it up. If I remember back in the day when, we had those little plastic floppy drives that you would stick into like your Mac or whatever. And it had like 1.4 megabytes of information. And everyone was like, oh, yeah, that's plenty. And then all of a sudden you got that shuffle thing where you're putting them in, and then you got a 20 megabyte hard drive, and you're like, whoa, how will I ever fill this up? And now, like, over in the corner, I have stacks of hard drives that I just like put a couple of terabytes of stuff onto it and then just file away into, So this room right here has more hard drive space than the entire world had in probably 1970 or something,
it's an evolution of George Carlin's bit on stuff.
Yes. Yeah.
Watch the George Carlin bit on stuff. Now we have hard drives to hold our stuff.
Right.
You bring a portable hard drive with you to, you have your laptop, you have to have a portable hard drive to put your stuff on. And then you go to some Hawaiian island and you bring like your phone and a smaller thing or whatever.
Exactly.
Holding your digital stuff.
That's actually literally what I did. I was just in LA visiting my brother, and I have a little tiny 1 terabyte solid state drive, which is how I do my videos on the road. So it's fantastic. Yeah.
No, and actually, like, I make these videos and I use software to edit, and I used DaVinci Resolve, and I had an older MacBook Pro with an Intel chip, and it was just getting slow. Right. And I went to an M1 MacBook Pro, and all of a sudden everything was really fast. And now at some point I'm going to be going to like 4K or 8K or whatever, and all of a sudden this is going to be too slow, and I'm going to need a new MacBook.
Yeah. So I think that's the general answer, is you always need more compute power, whether it's storage or whether it's exaflops or whatever of stuff. But the more specific answer for Tesla is, that and I know this a lot, not just from machine learning, but I've been doing like 3D animation for decades now. And what happens is when you see a Pixar or Disney movie or something, right? You see this, and that movie might be 90 minutes long. They didn't do 90 minutes of rendering. That's a lot, but they probably did somewhere around 100 times that much, because you have to try it, you experiment, you do early visualizations, you think you've got it right and it's wrong, and you have to do it. So every single second of that is probably 100 seconds of actual render time. And then you can pass that on to machine learning. It's the same basic thing. It's not like you just wake up one morning and you're like, this is exactly how to solve the problem. This is all the data we need. We'll run it through once and it'll learn everything and it'll be done. And that's just not the way that works. You do it and you're like, oh, that didn't work. And you do it again and you're like, oh, that didn't work. And you do it again and that didn't work. And maybe after 50 or 100 iterations of that, you finally get to what actually is starting to work. And then you work on the next piece of this puzzle. So what did we say, like 20 times in 18 months? So let's say it takes 20 days for them to do a full pass from the beginning to the end of the network right now. They could reduce that time. That's like, 3 weeks, basically. They can reduce that time to 1 day to do a complete retrain of their network. And I believe it's more like 2 weeks, but I'm just throwing out easy numbers, right? But basically, if you can do 20x the compute, you have 20x the capability. You're going 20 times as fast. That is a massive, massive advantage. And don't forget, like you said at the beginning of the recording, we're also dealing with Optimus. So it's not just cars. We also are going to be dealing with humanoid robots, and that's got to work. And I'm trying to remember the number that they threw out in one of their talks. I think they're utilized at something like 95%. Like
No,
they're
99.3%.
Yeah, 99.3%. It's just they have no spare compute cycles right now. And they said 80% of the jobs were high urgency jobs. So it's not like, oh, this can wait for a while. It's like, no, this needs to get done immediately. So they're completely throttled by the amount of compute power that they have. So yeah, it may seem crazy that they're trying to get this many exaflops of power, but it's super necessary. If they're going to do this and they're going to be able to iterate quickly, it's absolutely necessary that they can get this. And I'm sure they wish they had 100 exaflops like today. They would use it if they had
just
it.
So people understand, there are 400,000 or so cars on the FSD beta that are submitting probably ballpark of 10 gigabytes a day each of data up to the compute cloud. There are another 4 million cars that have cameras that are submitting some data up to be able to understand the world around it. So these compute clusters are processing video clips that might be 10 or 20 seconds long, and it's a huge amount of data. And I think they're processing, maybe, hundreds of clips or thousands of clips all at once. But one of the things I wanted to ask you about was, you just talked about the potential to iterate faster. That instead of taking 20 days to retrain the system, that 20-day operation now might take 1 day. There's something else that I've seen them mention occasionally about larger neural nets, that when you have a larger system, and the way Dojo was designed, it's able to handle some sort of larger, and I think I understand, but I don't really understand. What does it mean to have larger neural nets? I think the perspective I get is the larger neural net enables the computer to have a more general understanding of the world around it. Can you give some idea what it means to use larger neural nets?
It's actually a little bit complicated. So we're dealing with software and hardware. So larger neural networks, of course, is a software thing. That's just code that makes these neural networks bigger. But the hardware aspect of this, when we talk about 300,000 A100 GPUs, 100 exaflops, it sounds like, oh, just go buy that many NVIDIA GPUs, no problem. But that's just the tip of the iceberg, because you have to have them all connected to each other. They have to have CPUs that run them. More importantly, they have to have memory. What we were talking about, all those terabytes of storage, well, they've got petabytes of storage. And all of this stuff, they can't even hold on to this. They're just constantly throwing away data that they don't use anymore because they just don't have the space to store it. So all of this stuff has to grow simultaneously. And where Dojo really, really shines is it has high degrees. It's very, very compute efficient for what they're trying to do, but it also has super fast memory bandwidth. So they've designed it specifically to work on this type of problem, a machine learning problem with a large neural network. Probably transformers or something, although that seems to be going away. They seem to be wanting to move back to convolutional neural networks. A little bit technical. I did a couple episodes on that about Ashok and Phil's talk, but whatever that is, they need tons and tons of memory, and it has to go into the computer and out of the computer very, very quickly. And so a lot of what they've talked about at AI Day, where they really got into details, I think it was AI Day 2, they really get into details about that. And a lot of what they're working on is the efficiency of memory access. And what can happen is that, again, a bottleneck, you could have to read in a very large neural network. That takes time. And then you have to read the data in. That takes time. While that's happening, the computer is just sitting there. The actual processing units are just like, they're just like, no, right? So it could be the equivalent of 1,000 years of waiting, because of course they're running very, very quickly. They're just sitting there doing nothing for like 1,000 human years. Then they go like, oh, let's work. And then they shove the stuff off and they sit there for another 1,000 years waiting for the next batch of data. Well, it's not efficient. So a lot of what they're working on is to maximize the utilization of the compute cycles so that they're constantly flowing memory from what they need, the neural network architecture, and then through it and then out again without having to have the GPUs and CPUs and tensor processing units, all that stuff waiting around for more data. So what you've got, that's one of the big advantages of Dojo is it's not just a chip. It's that thing is huge, that tile. And a lot of what's going on there is the memory access, the fact that they've built it in sort of a 3-dimensional path so that the memory can come in, go down, right? It doesn't have to go across. It has a more efficient path that it can go straight up and down from the chip itself. And then there's a bunch of cooling and things because it's super, super hot. And just to be to look around a little bit, there are other solutions to this. People are doing analog computing now again, and there is other ones, which is compute on memory. That's not the actual word that they use, but that is actually you actually do computations on the memory chip instead. So you build the chips that they can do simple computations on the memory, so you don't actually have to pass things back and forth. So there's a lot of stuff going on. So yeah, like when I said it's complicated, it's like there's a lot of stuff that's happening around the actual compute cycles. As far as the bigger neural networks are concerned, that basically allows you to understand the world better. That's kind of what we've seen with the large language models like ChatGPT, is that they have like 174 billion parameters or something. That was 3.5, but I think it's somewhere around 500 billion now is what the estimation for GPT-4. But that's it's really, really, really big. It doesn't fit on your laptop. And so, again, it's just how can you move memory? How can you use compute cycles as efficiently as possible and get things on there, run them all at once, run the data that you need, have the big enough batches of data that you're training on all at once to make this all super efficient. And
so
yeah.
when I listen to Elon talking, or Ashok or Phil or anybody from the AI team talking, sometimes I hear like there's multiple neural nets running on the chip. And then I want to hear about this idea of a larger neural net. Is the larger neural net taking on functions that were previously operated by, let's say there were 7 smaller neural nets doing a whole bunch of tasks? Is the idea you create a larger neural net and it takes all those tasks under one umbrella? Or is there a larger neural net that's supervising all the smaller tasks and you're just creating larger neural nets to supervise more smaller tasks?
Right. Some of it's actually moving from software 1.0, which of course is more of just standard coding. So you would have somebody who would design a system like for stop signs. It's like, if you see an octagonal sign, then could be stop sign. If you see a red sign, could be stop sign, very simplified version. But you can have a very, very big amount of code that's just a bunch of if-then statements, basically, to try to detect things. You can move that from hard-coded stuff to neural networks, which you wanted to talk about the output, the control system of like actually driving, and that's the same basic deal. And we can talk about that in more detail. So that's one way that you're moving to larger neural networks, because you're having to take on that responsibility with neural networks. The other thing is, I don't believe that they don't have like a monolithic neural network. They have a whole bunch. They have a vision system with a whole bunch of neural networks that feeds into kind of a main, like, understanding the world system that then pops out to a bunch of heads, which are different types of things. It's like, oh, here's the stop sign head, here's the traffic light head, here's the lane head. So there's all of these things that it pops out at. And so you can work on different pieces of that at once. But as this grows, effectively, that it's not one neural network, but that whole collection of neural networks gets to be very, very huge. So it's a lot of stuff that has to be processed all at once. And then the even bigger neural networks, I believe, are actually the auto labeling neural networks. So we haven't talked about that, but it's not just training the thing that actually does the full self-driving. It's training the systems that actually do the labeling. Because when you're getting 400 million vehicles worth of data, even though they're not getting all of that, you're getting a lot of that every day. It has to be able to read all those videos in, has to turn them into labeled data so that it can train on that. And that is gigantic neural networks, because that doesn't have to fit on a portable computer. And so that's a whole other ballpark. That's probably, I think they said most of their work. So let's call it like 80%, 75, 80% of the work that they're doing is actually on those neural networks, not on the actual full self-driving ones. So those are all huge neural networks also. So there's a lot of stuff going on behind the scenes.
Let's just be clear for people watching. What the auto labeling network is doing is the car is driving down the road and it sees something, and maybe it's not sure what that thing is. There's a term that I've seen used in a presentation called flicker, where it identifies an object and says stop sign. And then the next instant it says, wait, that's a yield sign. And the next instant it says, wait, it's a stop sign. So the car is indecisive about what that object is. You want it to recognize objects as quickly as possible. So if it's flickering, you need to retrain the model so it makes that identification more accurately and quicker. And so the auto labeling is the cars are driving through the world and they're seeing things that might not be a stop sign or yield sign that we commonly understand, but maybe it's a piece of paper flying in the air. And is that an object that would hit it, that would cause a problem if we hit it, or it's smoke, or it's fog? There's a whole variety of things out there that have to be labeled so that the cars that give those objects, I'll use the term semantic meaning,
right?
So that the car has a better idea what to do about them. That what the car is doing, what the chip in the car is doing, is and the software is identifying objects and predicting what they're likely to do and where they're likely to move. Because if you have a sense of what we're trying to build here is an understanding of the world, like a 3D model of the world around the car. If you know where everything is around the car and you can predict where everything is going to move, then the next step is choosing a path that lets you navigate between all the objects. And if you don't know where everything is, so you don't know what everything is and you don't know where it's going to move, then it's much harder to navigate. And we all do this,
right?
Our brains are designed to do this fast. We have biological neural nets and 2 cameras, and we see the world and we recognize stop sign. We don't flicker between stop sign and yield sign. If we see a stop sign, we know it's a stop sign the instant we see it. There are objects we're not sure about. And we effectively train our own brains from a very young age to start recognizing things. So that's one of the challenges. But when I look at where we're heading, I think the first challenge is, and I wanted to come back to a problem that I've noticed in the Tesla community, is you'll have somebody saying, my car's been running this stop sign and I've had this problem for 7 months and Tesla hasn't fixed it yet. And my own reaction to that is, well, I read the release notes, and the release notes are not 3 people complained about running a stop signs in these circumstances.
Right.
The release notes are, we've improved recognition of this kind of object by 32%. We've improved prediction of vulnerable road user movement by 16%. What they're focused on is improving the understanding of the world around the car. If you don't know what things are and you can't predict where they're going to move, then fixing these problems is not solving anything. The first step is to improve the car's understanding. Can you put that in your own words? What are they trying to improve? When we read the release notes, what are they telling us?
Yeah, I think actually what I was having a conversation with James Dalma, and it was a very insightful comment. He was like, don't optimize too early. So he's saying, look at these people complaining about all of these things. He's like, you don't want to spend a huge amount of resources fixing something like that when you're still having problems understanding the world. So fix that stuff first before you worry about these individual weird cases of cars running stop signs and stuff. So number one is just be a little patient. But number two, I think your flicker comment is actually really, really useful for people who've had full self-driving beta. You've had it for a while. The early versions, remember that like cars would flicker, signs would flick, like you would see it in the visualization. They would disappear, appear, disappear, move around. That stuff is being reduced and reduced and reduced. Every version that comes out is more like, it's just like a video game. It's just there. It doesn't move around. And when you look at something like that, you're like, oh, that's a big improvement that's going on. The reduction in what we're seeing in flicker is huge. But you don't want to look at these weird edge cases, which are way downstream. That's at the bottom, right? You have the whole vision thing, the understanding thing, and then there's a head that's like stop signs, what to do at stop signs. Well, if you worry too much about that, you can expend a great deal of engineering effort on something, and then something above that gets changed, and that just blows that apart and it doesn't work anymore. So why would you bother fixing something that you could spend days or weeks working on that's not going to be useful in a month when they do their major new update? So there are a lot of people who are very impatient, including me. I hate the speed limit thing because I pull out of my neighborhood. It's a 50-mile-an-hour zone, and it always says 25. And I'm like, come on, guys, can you fix this problem right now? But they have bigger fish to fry still. It's like, okay, so that's an annoyance for me and it's an annoyance for other people, but that's not their focus right now. Their focus is to get that core vision, semantic functionality working, and then they can worry about these small things.
Right. Yeah, and I just want to say, like, I don't have a lot of problems with FSD beta. My major problems are it's not as aggressive as I want to be, so I take over because I want to get past that car, or it doesn't go as fast. Like, it won't, if you set a speed limit for it, it won't temporarily exceed that speed limit in order to get somewhere.
Yes.
And my attitude is, no, I want to get around that car. Let's go faster. And I just take, rather than accelerating, just stepping on the accelerator, I take over. And then its lane change behavior has been pretty bad. It makes like a left lane change 0.2 of a mile before we're about to make a right turn. Like, why is it doing that? But to me, that's like small potatoes. This is a small problem. The bigger issue is it understanding the world better? Is it identifying objects? Is it predicting movement? I think all these things are getting significantly better over time.
Right.
So I wanted to ask you about this moment. You mentioned Ashok's talk at CVPR. There was this moment where he was asked a question about when something was going to be in the cars. And he paused and he said, probably by the end of the year. And I didn't understand what the thing was that isn't in the cars, because I thought they were talking about the occupancy network, and I thought the cars were already using the occupancy network. So what was the, I didn't understand that question. What were they? And it's too long to like, I can include the clip, but I think there's too much context going back, you know.
Well, if you don't mind like including it in the description, I have 2 videos on that. So I'll give you the links to those. And I can only give a little bit of an overview here because I spend like an hour and 20 minutes or something working on this, though. You know, if people really want to dive deep, then look at those videos. But and this is absolutely speculation on my part because they're being a little bit careful about talking about this. You can hear both him and Phil in another CVPR talk being like, we can't really talk about this right now, but big things are afoot. And my personal thought on this, not Tesla's, I just want to be very clear about this, is that what they're working on is a foundational world model that's much more aligned with something like foundational models for large language models. So, so that really doesn't help. Probably most people are like, what the hell does that mean? Well, so yeah, go ahead.
Well, this is kind of goes to this question of like smaller neural nets that are doing like a lot of different things versus a larger neural net that's getting a larger understanding of the world. And I think what you're saying is right now they're still operating a whole bunch of neural nets and they're starting to get a sense of the world, but there's a foundational model that will have a much better understanding of the larger world, and then everything fits into that.
Right. Yeah. And so what it comes down to is that, and I think the large language models is a good way to look at this. So I'm going to use this as an analogy, although it's not perfect. But the way people use ChatGPT, right? And I think everybody's using it nowadays. It's a fine-tuned version of a foundation model. So let's talk about the foundation model first and then the fine-tuning. So the foundation model is GPT, which is generative pre-trained transformer. And that actually includes in the name what's going on. So what they have, and Elon Musk just had a whole big brouhaha along with other companies about shutting Twitter down to keep OpenAI and other people from scraping their web. But what's going on is that these companies over time have just gathered all the language from all of the internet and everything they can get. And they don't have human beings labeling this data. That would be insanity because it's trillions of words. What they do is they just dump this into a giant training thing, which is where the hundreds of millions of dollars of training comes in. They take a neural network, they give it all of this language. And what they do is the pre-training part is that they basically give it a sentence. So it's like the cat sat on the red sofa or something. And that's just something that somebody's written on the internet. And it will block out pieces of that sentence. And the neural network will have to go in and figure out what words are missing. So maybe red, maybe sofa, maybe cat. It'll block that stuff out. And it has to generate the next words as it goes. All of that is unsupervised. No human being has to have anything to do with it once they've got it all set up. They just let it run. And that's how it can chunk through trillions of words at once. Then that gives you a really good foundation model, but it doesn't give you something that's usable. If you ever, I tried to use GPT before they had Chat GPT, and it would generate stuff, but it was like gobbledygook. It was like, oh, what the hell? So then what they do is they use what's called reinforcement learning with human feedback, which has people they go like, I'll write you an answer as an example. And then it goes like, okay, thank you. And it learns from that. And then later the GPT thing will generate like 4 answers and the human will go like, I like answer A best in this situation. So using humans a little bit at the end to fine tune it makes it suddenly really, really good. It works really well. Okay. So now full self-driving, a foundation model. And this is, I believe, what we're seeing because they've been giving us clues about generating actual outcomes, like generating videos that the car would see, is that they're giving it, just like words, they're giving it a chunk of let's say a 10-second piece of driving. And what they do is they block off the end of that section. They give it this neural network architecture, which is a mystery. I have no idea exactly what it is, but they give it something, that architecture, and they feed into that trillions of seconds of video. Or at least billions, I don't know. It's a lot of seconds of video. And they keep masking off the end of it and going like, what's going to happen next? What's going to happen next?
They ask the AI to predict the next second.
Exactly. So it's generative pre-trained.
And then it looks at what happens in the next second. And if it's mostly and whatever it gets wrong, it now trains on, okay, this is how I can do better. This is how I can predict better in the future.
Yeah. And of course the difficulty is that the world is way more complicated than language. It's like predicting the next word is like a word, but like, what the hell? The world is like this crazy thing. But if you can make that work, then you can have the car always predicting what the best next move is. And they even had that little video where they said, look, we can actually tell it to turn right and it will generate a right-hand lane and move over there. Like, that's actually generated video. It's not real. And so in my mind, what's happening here is that they're working on this foundation model, which doesn't have to have labels, right? You don't have to have a human being. Once you set it up, you just run it and you just keep feeding it stuff and it learns. And then the last step is you put it in a car or you put it in a simulation and you have a human being like drive it, and the human goes like, oh, that was terrible, bad. And so they give it a negative. So they're giving it feedback to say like, that was super uncomfortable because you just changed lanes 3 times in 5 seconds and the car's jerking around and whatever. That human feedback is like a last little piece that goes on to the end of it, and that most of the training, but this is a completely new architecture. So again, my speculation, Tesla has not admitted to this. My prediction is that I hear that AI Day 3 is pretty much a definite for sometime in the fall, but at that point, they will probably reveal this. They'll be like, yep, this is what we've been working on, and it's a couple of months away from being in some people's cars. So, and that will be amazing. That'll be a huge movement.
I feel like we've seen hints of this before, though, that there was some moment, I think it was AI Day 2, where they were talking about, you see this pedestrian, and they were able to predict the pedestrian's movement.
Yes.
Like very effective, and that's a really important thing, and that's something you see in the release notes is improved prediction of vulnerable road users like pedestrian, motorcycle, bicycle, things that if you hit them, they're more likely to get hurt. Right.
Versus
car, which is not a vulnerable road user, and the system is designed to be very careful about vulnerable road users, because if you hit them, it's a problem. Do you need a minute?
No, 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 it's fine. I was writing something down for a note for myself because I was like, yeah, that's a good idea.
So if it predicts that second long clip, you show it 10 seconds, predict the next second, and then a vulnerable road user, a pedestrian, goes back a different way than predicted, then okay, we've got to retrain that, and it identifies where it gets it wrong and retrains it. So, I mean, what I'm seeing, that there's Elon, he's always overconfident about when they're going to get to the next level.
Right.
And let me just I wanted to ask you about
which
this.
Actually goes to your shirt. Your shirt is the perfect shirt for today.
Yes. No, FSD is turning impossible and delayed.
Yeah.
Starship is turning impossible and delayed. Neuralink is turning impossible and delayed. All these things are turning, what Tesla does, what SpaceX does, what Neuralink does, a lot of these things. Honestly, I think ChatGPT, I just want to mention, actually, just really quick on ChatGPT, because you brought it up and I wanted to talk about this. How I've been using ChatGPT lately is I had a novel I was working on that I put on hold because I got to chapter 8 and then I just didn't keep going.
Right.
So I fed ChatGPT, would not take all 8 chapters.
Right.
I was able to feed 3 chapters in and ask it, and not say, the real value for me was I would have a conversation with ChatGPT.
Right.
What do you think about the first 3 chapters? And then I would say, I would say, write a chapter 4, and it's chapter 4 was not at all what I wanted to do. And I said, okay, here's my chapter 4. Does my chapter 4 flow well from chapters 1 to 3? What do you, like an actual conversation? And then, could you compare your chapter 4 and my chapter 4? What are you seeing differently? And then, all right, let's incorporate this part of what you did in chapter 4 in my chapter 4, and then went through and did the rest of the book, where I might tell it, here's what I want to happen. Like, once we got past chapter 8, I hadn't really written the story. I had the idea in my head, but I hadn't really written it. So, like, all right, write chapter 9, and this is what I want to happen in chapter 9. And what it's really good at, I'm not good at generating dialogue. I'm not good at generating descriptions of the scene. Right. So it's actually much better at that. And then, like, I go through and I actually had my daughter read it. My daughter had some feedback, and I'd go back to ChatGPT and said, hey, could you add some dialogue between these 2 characters? Could you write something that develops this character more like these? Like, I actually had this moment where I realized it's a husband and a wife and 2 kids. Right. And I really hadn't developed the kids at all. Right. So we added a chapter just where, like, all right, I want you to put a chapter in where the 2 girls are doing something. And I gave it a lot more description than that. Right. It came out with this chapter, and like, okay, wait a minute, and had to fix a few things. So it's like I'm collaborating with ChatGPT to write a novel. Yeah. And this is, for me, this is mind-blowing. Like, the fact that it is basically, I mean, I'm paying $20 a month, right, for GPT-4, but it is basically a free editor for my novel. It is a free coach in how to write it. It's a free service at providing writing assistance. It's if I were to pay a human to help me with this, it would cost me thousands of dollars. Yeah, and it would take a lot longer too. Yes. If you said rewrite chapter 4, they'll be like, I'll get back to you next week, right? It'll take them 4 or 5 or 7 days to write that chapter. 3 seconds. Yeah. It's like 3 seconds before it starts writing, and it's 15 seconds and it's done. Yeah. And then the challenge is some of the things that you don't know. And the same thing would be true if you hired someone else to help you with this, by the way. You don't know whether it's lifting text from some other novel. Yeah. But I don't know if I hire a human to help me with that. I don't know that. And if I do it myself, I don't know that somewhere in the deep recesses of my mind, I'm not drawing from some novel I read in the past. Exactly. Can you just talk about that? I know we're off on a topic away from FSD. That's okay. But this idea of ChatGPT copying content that it found somewhere else, my sense is it's not actually copying content. Right. It's actually doing what we do, which is, you and I have read a lot in the course of our lives. We've had a lot of conversations like this one in the course of our lives. And somebody asks us a question and we start talking like we're doing right now. Yeah. And we're generating words. And I don't think I'm generating one word at a time probabilistically, but sometimes it's hard to distinguish what we are doing here and having this conversation with what ChatGPT is doing when I have a conversation with it. Can you distinguish, like, do we really understand how you and I generate words? No.
No, the weird thing is that I've thought about this sometimes while having conversations, and it can really like stall you out because you're like, am I thinking of the next word? So you can like get really in your head about this. But when it comes to the question of whether these things are copying, and we can go to images too. I think images, there's a lot of lawsuits right now with like Stable Diffusion and Midjourney and stuff. And Getty Images and are like, hey, you're copying our images and all this. That would be with a writer or an artist or whatever. It's the same thing. No, they're not. They're trained on it. Now, if you want to say that's illegal to train on all of this data, that would be like saying like all these books that I read back here, because they're copyrighted, most of them have copyright still. It's like you can't have that in your brain because that was copyrighted when you read it. I was like, well, okay, how are you going to stop me? Because I'm generating my own version of it. I'm not just, if I copied it, obviously that would work. But the way GPT works and the way something like an image generator works is it takes all this stuff in just like a human does. And then you give it a prompt and you say, write me a chapter or paint me a picture or something. And it does it. And yeah, of course it's using what it's learned, but that's how a human being doesn't pop out of the womb and suddenly be, and it's like art, Leonardo da Vinci painting, or engineering drawings. It's like, you don't just do that. You have to learn. And that learning process is sucking in all this information from everything else. But if you're creative, you're generating it yourself. And just in the name of this thing, it's a generative pre-trained transformer. It's generative. It's generating this. It's not a copy. It's not CPT. It's GPT. So
no, and but just for disclosure, the image behind me was generated by Stable Diffusion. I said hot car on a country road at sunset, and it came up with this. I thought it was pretty cool. And just on my novel, like, okay, I wrote it with ChatGPT's help. I actually just hired an editor to work on to just review it. Like it's hard for me to come back and read it and get it. I wanted somebody else with an objective viewpoint. My daughter's read it, and I've got a couple other people taking a look at it.
But so you finished it now, right?
Well, draft? I'm finished, except I'm probably going to go back through and make substantial edits. But I have like a finished 20 chapter, 15,000 word book.
That's really impressive because that means that something that had stalled you out. And I've done this experiment too. But ideas that you've had that you were like, I'll do this, and then you stalled, you're now able to complete that process, which is really amazing.
Yeah, no, and I have two more novels that I'm going to write. One of them was supposed to be a movie, one of them was supposed to be a TV series, but it's like, well, I'll write the novel first.
Right.
And like the next two are, I'm a retired lawyer. The next two are lawyer related. The first one is not lawyer related. But anyway, I find that like it's amazing. And I think what we're seeing with, when you translate this back to self-driving, and when you translate this back to Optimus, we walk through the world and we see, over the course of our lives, we've seen a lot. And now we're moving forward, and we are basically subconsciously, we're predicting what's that car going to do? What's that child going to do? I'm at the gym. What's the guy on the next machine going to do? Is he going to get off that machine so I can use it? There's all these things in life where we're basically predicting what's going to.
More to the point, is he just about to move to the machine I want to move to?
Right. No, and I just got back from the gym, and is that girl interested in me? Right. If I approach that girl, what's likely to happen? We make all kinds of predictions. I don't think we think of it that way, but in a sense, I think we are doing that, and that having the cars and Optimus model the world in that way may not be that far off from what we're doing. And it's really interesting question that I'm going to ask you is, how do we differentiate human intelligence from generative AI?
Wow.
Big question.
It's a big question. And there's a bunch of pieces to that question. That the most important part is we really have no idea still how we work. So that makes it really hard. Yeah. I took a couple of courses during my master's degree in AI in psychology, and they were on the brain and how we all think. And the basic outcome of that was nobody really knows what the answer to that question is. Nobody really knows how we're conscious and what happens. My personal opinion is that it's an emergence of complexity, that we have a very complex series of little things happening in our brains. And that consciousness, you can see it in animals, right? There's a degree of consciousness, the more complex the animal is, up to things like dogs and cats and stuff, the more quasi-conscious they are. And then humans are just at the top of that game. So it would, in that, if that's correct, that would make sense that as you get more and more complicated language models driving whatever, that they're going to become more and more sort of quasi-conscious. Now, the danger is, of course, to anthropomorphize that and say like, oh, the car is thinking this right now, or the car's being wussy and not being aggressive enough, or the large language model is too politically correct or something. It's like, no, that, you know, they think really differently than we do. And so it's unfortunate that I think a lot of people, and I do this too, because it's just easier. You're like, oh, the car isn't aggressive enough. Well, it's like, that's not really the answer, because that's a human emotional response to the situation. And I'm very much like you. It's like, if I'm behind a truck, I'm going to like get around that truck, right? If I possibly can, because it's like annoying me. The computer is not annoyed. It doesn't care one way or the other. It just has its inputs and its outputs, and it has some degree of something that it does. And one thing that I've found very instructive is if I'm a passenger, like if my wife is driving and she's using Tesla's full self-driving, I'm way more lenient than when I'm driving, because when I'm driving, I'm having to pay attention. And when I have to pay attention, I'm of course going like, I would do this right now. I would do this right now. I would do. But if I'm reading a book or sleeping, I don't care whether it's full self-driving or not. If it takes an extra 10 minutes to do a 5-hour drive, whatever, because it didn't pull around that truck at that point. So I think one of the reasons why we are so hyper about what's happening with full self-driving and all the little niggling details is because we're still responsible. The day that someday when Tesla goes like, yep, we'll take responsibility for this drive, you know, and that 20-minute drive or 30-minute drive, you're not going to pay nearly as much attention to what's going on. If it stops a little bit too long at a stop sign or doesn't get around a truck, you might notice it, but it's not going to stress you out, because it'd be like somebody else driving.
I love your point about being in the passenger seat, because I feel like, of course, I'm the best driver in the world.
Yeah.
So
so say we all, right?
right. So when the car makes a mistake, my gut reaction is it doesn't drive as well as me. I will say, by the way, I think at this point it actually navigates better than I do. But like some driving decisions, I feel like it doesn't make driving decisions that well compared to how I make decisions. But one of the things I've suggested to people is think about the worst driver that you occasionally ride with in your life.
Right.
That someone in your life who drives you around. It could be a family member, it could be a friend or whatever. Every once in a while you get in that person's car and you sit
the one that you probably try to avoid driving with as much as possible. Yeah.
I've had a couple of moments in the last couple of years where I was in a car with somebody. I was like, oh my God, I can't believe how bad this person's driving. And that person has a driver's license, is allowed to drive on the road, and generally doesn't crash very often. Right. And I ask people, does FSD beta drive worse than that guy?
Right.
Right. And when you ask them that question, like, oh, there's this look of recognition on their face. Like, yeah. Well, and I still think there's a ways to go to getting better than, let's say, so like, stop thinking about being better than the 99th percentile human and say, is it better than the 10th percentile human driver? Because we let the 10th percentile human driver drive. Right. And then you add in that it's not going to get drunk. It's not going to fall asleep. It's not going to get distracted by the girl in the bikini. I get distracted by the girl in the bikini. It's not going to get distracted by a conversation with someone in the car. It's got 8 cameras seeing the entire world 24/7, 30 plus frames per second. It actually has better vision than we do. So it's going to make you notice the mistakes that it makes where it does something worse than you would have done. You don't notice the moments where it does something better than you would have done. Right.
Yeah, it's like a negative bias. We always have a negative bias, but I think objectively speaking, I can think of 2 or 3 people right now in my head, which I obviously won't say, but objectively speaking, I would way rather get in the car and sit in the back seat with full self-driving and not have anybody in the driver's seat than to drive with those people. Like objectively speaking, the car is going to get me there. The odds are much higher that I will get there in one piece than with that person.
Yeah, and I would relate. This is probably more than a year ago now. My older daughter was driving, and we were going to visit my mom. And sorry, I was driving. I got tired. I asked my older daughter to take over, and she's just not that experienced of a driver. She lives in New York City.
Yeah.
And she took over, and I said, hey, would you mind running FSD beta and supervising it? I was so much more relaxed with FSD beta driving and her supervising than because for the first few minutes she drove. I was so much more relaxed because I knew how FSD beta drove.
Right.
And I had driven it on these roads, so I knew how it drove. And just having her supervise it was so much more relaxing than having her drive. So I wanted to turn to Optimus for a second. I look at the future of, to me, there's this term that FSD is a solved problem. I've heard Jim Keller say it. I've heard Andre Karpathy say it. I've heard George Hotz say it. Not that it's fully solved, but the path to self-driving is pretty apparent that we're getting there. So now you have this layer of Optimus coming along, which doesn't have to deal with high speeds. It generally doesn't have to deal with, at least in most circumstances, doesn't have to deal with high-speed objects in its environment, but it has to deal with a much more complex and rich environment. And it has another thing. So like FSD doesn't have to climb stairs. FSD doesn't have to get in an elevator.
Pick up something. Yeah.
Right. Well, that's so there's one thing is the way I see it is there's two major things that are going on. One is understanding the world around you. Well, three things. One is understanding the world around you and then navigating through that world. But there's a whole nother level when you're going to start manipulating objects. FSD does not manipulate objects. I could imagine a world where FSD is blocked in by something, and I've done this, like you push something out of the way with your car.
Yeah.
If they're inside, you might decide I'm going to knock that cone over. Like FSD won't knock a cone over.
Right.
Or I got jammed into a parking spot and I don't have a way out of this. And you know what? I'm just going to back this car up a little bit. I'm going to push this car a little bit out of the way so I can get out of this parking spot. I've done it. I don't know if you've ever done it. I shouldn't do it. But at some point, FSD, but that's a very limited amount of object manipulation. So to me, Optimus having to learn to manipulate objects is a whole nother level of challenge. And I feel like when I talk to people about it, they think that's easy. And I don't think that's easy at all. Can you comment on the challenge of learning to manipulate objects?
Yeah. So I think that, again, this is actually relates back to, I think right at the beginning, you were talking about the single stack version 12 of the full self-driving. And a lot of the output controls on the car right now are old school code, which is just, again, if then statements kind of things. But the thing is, you can get away with that in the car because it's like, turn the steering wheel 2 degrees to the right, press the accelerator 2% more or something, very, very simple stuff. So that's the least important part of that. When you move to Optimus, that becomes the most important part. And that's where having a full stack neural network is hugely important because, like you said, the sort of balancing act of this is that the robot is not moving, the humanoid robot Optimus is not moving through the world very quickly, maybe a couple of miles an hour, as opposed to a car that might be doing 80. It's not nearly as heavy. So, everything is much less critical. In a car, it's like, don't screw up.
Don't
the
crash.
Number one thing, if the car is ever a little bit wussy, it's like, don't screw up. Right. With the robot, it's not going to have to be nearly that careful. If it bumps into something, whatever, it doesn't matter that much. Even a human being, once it has some sort of coating on it, right now it could pinch somebody or something. But the robot itself is just 125, 130 pounds. It's not that much. So if you run into it, like whatever, it's just like running into a person. So all of that stuff is easier. The environment is much richer, but then the really, really, really big thing is that it has to be able to, like, pick up something. Like, this is a very, very fine motor coordination kind of thing to pick up a pen. So that part of it is going to absolutely necessitate, I think they set out 200 and something degrees of freedom, as opposed to a car that has basically 3 degrees of freedom. And every single one of those interact with each other. So if you reach your arm out, your balance point changes and your body has to shift slightly this way. And at the same time, your head has to tilt just a little bit to keep your eyes straight, so you're not looking like sideways. So the amount of like interrelatedness of all of these output controls is huge with a humanoid robot. And so you absolutely have to have a neural network output stack that's on there. And then the beauty of that, of course, is that once they get that thing working for the robot, they can recycle it back into the car because it's just a subset of that problem. So yeah, I think, gosh, is it Scott? Somebody always says, like, the goal of full self-driving is not to interact with the world. It's basically to avoid everything. Don't hit anything. The goal of Optimus is to interact with the world. So it's a very, very different output. It's really important that it interacts properly. So yeah, it necessitates having a neural network output stack. And that's going to, that whatever that thing is very different than what's going on in the full self-driving vehicle at the moment, it sounds like.
All right, so let's bounce back to FSD for a second, because I don't know if we talked about it on camera. We think they may have talked about that before we started.
Right.
We're heading towards version 12 of FSD,
Right.
maybe by the end of this year. And I wasn't sure if that's what Ashok was referring to when he said by the end of this year. I feel like Elon has said by the end of this year, we're going to go to version 12. And version 12 may be a combination of this foundational model and those last decisions about how much to turn the wheel and how much to step on the accelerator or the brake or the control decisions are currently a human coded this, and that's going to shift to the neural nets making the decisions. Why does it take so long to go to that? Do you think they already have that in alpha cars just as a start?
Almost definitely. And I think the reason why is because it hasn't been very important. They're working on the biggest problems, and for the car, the big problem is understanding the world. And again, don't hit anything. The output control of a car is really simple. Again, it's just turn a steering wheel, press an accelerator, press a brake. That's it. It's very, very simple output. In terms of physicality, like that's probably the simplest thing you do all day. Like just walking around your house is way more complicated than driving a car in terms of output control. Now, understanding the world and making sure that you don't hit things, yeah, that's complicated. But the actual like moving your hand like this, whatever, that's like simple. So I think it just hasn't been important. It's not at the top of the stack. But when we move over to Optimus from the get-go, I'm sure that they knew like we can't just have people have tried this with robots over decades.
200 degrees of freedom.
Yeah, it's what happens is that the robot's completely jerky. You can look back at like oh gosh, was it Asimo or something like that? The old Honda robot.
Yeah.
It was like, whoa, it walks and all that stuff. But you can see just how clunky it is as it's walking. And it's just, and that's it. It's just walking. That's all it's doing. But when you get to something like Atlas robot that Boston Dynamics is doing and is doing backflips and all of this, there's a lot of immense amounts of hand coding that goes into making a robot like that work. And I think Tesla knew from the get-go, that's not the direction we want to go. We want to allow a neural network to control this and to operate this thing from the start. And that means it has to learn. And the beauty is that they have a simulator. So it can try to pick up a pen 1 billion times in the simulation and 999,990 times, 1,000 times it fails. But the ones that it actually succeeds at, it's like, oh, I'm going to follow this. And it trains the network. And then, of course, you move that from the virtual world into the real world. And it probably will fail again since there's not an exact match, but it's pretty close already. And then you can fine tune it.
Right. So thinking forward to where Optimus is going to play a role in our lives. I've been thinking about use cases for Optimus, and I generally think about it in the working world, not limited to factories. I feel like a lot of people are talking about Tesla using Optimus in factories, and I think that's overly limited. And my favorite example is, my two favorite examples are, one, you have a secure facility and you have guards patrolling the perimeter. And you have 10 guards, let's say, patrolling the perimeter. I'm making up numbers, right?
Right.
We're going to deploy 10 Tesla bots, and we're going to reduce the number of guards to 3. And they're at a more centralized area. And the bots walk around the perimeter, and they don't have to manipulate objects. All they have to do is walk around. So you've eliminated one of the challenges, right? And if they see something, they recognize it. If it looks like a squirrel and it knows how to recognize a squirrel, it knows that's not a security threat. If it sees a human, like, wait a minute, I wasn't expecting a human to be here, it alerts the guards at the central area, and the guards are aware of it. That seems like a fairly straightforward use case for Optimus. And the guards walking around the perimeter are probably making $15 an hour. So if you can replace guards at $15 an hour with Optimus, and then their cost to the employer when you had a workers' comp and other expenses, maybe $20 an hour, that generates a lot of value for that employer.
Yeah. Well, and not to mention, let's just say from a security standpoint, every 2 hours, those guards need a 15-minute break, which means you're down in your staffing for that particular time. So there's less. Yeah. So that's actually a really good incidence of, whatever. It's a really good example of what would work really well for Optimus, like right now, pretty much. It could probably
do 2 shifts as well, or even 3 shifts, with charging breaks. So that's one. And then the other one, I used to work at Burger King when I was a kid, and I just sort of imagined a hypothetical fast food restaurant that has 10 workers. They usually have less than 10 workers nowadays, but let's assume they have 10 workers. And you bring in one bot that's able to do enough routine, mundane, boring tasks that
Right.
you can reduce your staff to 9. And it's taking out the
Right.
garbage, it's mopping the floors, it's not like putting a burger together, right?
Right.
It's doing some mundane
Quite,
stuff.
quite honestly, I will tell you one that would be really, really helpful from a comfort and a safety standpoint would be like operating the fry machine, because that's very dangerous. You've got boiling oil there, which is number one, uncomfortable to stand around. But number two, I imagine a lot of workman's comp claims are filed because people spill boiling oil on themselves.
Oh no,
And
we had a guy stick his hand in it.
oh my gosh. Oh, geez. So yeah,
He leaned on the cover
oh,
to the boiling oil and fell in and burned his hand. He got promoted, I got fired. It's just hilarious. I wasn't there that day. I wasn't there that I'm not saying I got fired for the incident, but the management of the Burger King apparently thought he was a good employee and I wasn't a good employee. He eventually got fired when they found alcohol in his locker. It's just hilarious. But
right.
there's cleaning the bathroom is an unpleasant task. If you can have identify a series of tasks, and let's say they're making 15, they cost the employer $20 an hour, you're saving the employer like $80,000 a year if you replace a $15 an hour job with whatever the minimal workers' comp and other costs are. You're basically saving the employer $80,000 a year if that bot works 2 shifts.
Right.
So when I look at where Optimus is going, I hear people saying, well, Tesla's going to build 100 bots and put them in the factory. And I look at it and say, that's not enough. If you want to train Optimus to work more effectively, you need thousands, tens of thousands, hundreds. Look, we have 400,000 FSD beta vehicles.
Right.
And what we need to train bot to do is more complicated than what we're training the cars to do. So I think Tesla, and let's suppose they manufacture at scale and it costs them $5,000 a bot to manufacture at scale. That's only $5 billion for Tesla to make 1 million bots. And then the question is, well, where do you deploy them? And I don't know if there's a market for this, but I would pay $25,000 for a beta bot. I call it the beta. I think they need a bot beta program.
Yeah.
And I'll take one with me country line dancing, and I'll take one with, whatever it is we're doing.
Just help put it in the car. It's a conversation starter. You've got I've got a robot in the car with me.
Hey, if I walk into country line dancing with a bot, you're going to be noticed, right? And sorry. So I think that there's real potential. Like, I think Optimus learns faster if you create more bots and you put them in more situations than if you create a small number of bots and just keep them in a factory. They're not going to learn. You're not going to learn as much. And if you're going to increase the compute power to 100 exaflops and then 1,000 exaflops, you want to generate a massive amount of data, and you want to train. And the more compute you have, and the more edge cases you expose the bots to, at some point you're going to have a mop the floor module that you can download. At some point you're going to have a sweep module. You're going to have a clean the toilet module. And I think we're heading towards a world where, like, my mother passed away, but she was in an assisted living facility, and it's hard to get people to do that work, and it's unpleasant work. And you can imagine a resident has an accident and needs to be cleaned up. Humans don't really want to do that task, and frankly, it's a little bit of a health risk to do that task. It may be that you can train bot to clean somebody up while the human has the polite and cordial interaction to soothe the elderly person while they're being cleaned. I think there's a lot of potential to solve a lot of problems in our society and get work done that we don't want to do. And there's go ahead.
There's another, I agree with you that there will be, if Tesla wants to, there will be a beta market, because there are a lot of people, if they said it's $30,000, there's a lot of people who would just get one. Even if it didn't really have much of a purpose at this point, there are people who like that. But speaking of elderly, I think of So, but like my parents, they don't live in an assisted care facility, but they do need care. And so having a companion, like, they have each other, but what if you were by yourself and you were living alone and you're older? The bot wouldn't just be there to do tasks for you, like sweep the floor or clean the bathroom or whatever, but it could be a companion too. If you put a large language model on it that it can have a conversation with you, then we're talking, Right. That's the kind of thing where a person could actually, and I know that romance is coming and things like that too but I'm thinking like for that particular case where you have somebody who's very lonely because they're alone and they're a little bit shut in because they're not physically as active as they could be. It could be not a lifesaver, but an emotional lifesaver. That could be a huge thing that could be very, very advantageous for a large segment of the population.
So I've got a little bit of a tangent, but related to this. I think you have FSD beta. I drive FSD beta. When I intervene, there's a prompt and you hit the microphone button and you can record a voice message. This is what went wrong. Now, I don't think that there are a series of employees who are listening to all these voice messages.
No.
I have a theory. My theory is that they are using our voice messages to train a large language model.
Ooh. Or at least to fine tune that model. Yeah. Yeah.
That they are taking our voice messages and they're correlating our voice messages to what video was observed.
Right.
To use our voice annotations to understand spoken language and interpret what did he mean when he said that. Because I don't understand how it would be useful otherwise. There's no way that if there's 400,000 beta testers and we each intervene once a day and hit the microphone button, they don't have enough employees to listen to 400,000 messages a day and review the video. Like, so what possible use would there be for that? And I think they got rid of it for a while, and I think it occurred to them, hey, this is a lot of data we can use.
Right. And well, it probably gives them a sense of the criticality of the intervention too. Like even beyond what the person says, the fact that they felt like it was necessary, because sometimes I just disable it because I'm like, I want to drive in the other lane and go faster or something. And I'm obviously not going to push the microphone button then. But it's like if something happens and I feel strongly enough about it that I actually push the button and make a comment, that should automatically move it up in terms of but I hadn't thought about the idea that they could use it for training or fine tuning. And think about like with the Optimus bot, that would be something like you say, I don't know, go get me a beer or something, and it brings back milk. And you're like, no. And then it could actually say to you, I'm really sorry, what did I do wrong? And then you explain it, and that could then be utilized as part of the training regimen and a bot would be there's very little friction for that, since it could actually ask you in a voice to tell you what's wrong, to tell it what's wrong.
I just think that they're thinking down the road that you're going to want, for robotaxi, you're going to want to be able to tell, but you're sitting in the back seat. You want to say, hey, I want to get out over by that gas station.
Yeah.
Right. Which is not what the current routing is. Or you've got Optimus and you say, hey, I want you to do X. That they need to start training on voice now. It's not that they're using what we say to train FSD. They're using what we say to train understanding of human language. Right. Because I don't know if anybody is really doing a lot of applying large language models I think they are applying large language models to spoken language, but I think what they're really doing is they're converting the human language, the spoken language, into text and then processing it as a large language model.
Yes.
And if you took human language and directly processed it into what was that, what's the meaning of that, without converting it to text, that might be more effective. So that's a theory. Think about if you had 400,000 voice messages a day and you had real world data to correlate to. It would help you understand both the real world and how humans talk about the real world. Yeah. It's going to be really essential for bot. And I think it's essential for the cars as well in a robotaxi world. Right. Oh.
Well, just listening to my wife, like if she intervenes, the way that she describes the problem is very different from how I do. So I think you're right. There is a big advantage to like, what is the range of the way humans describe problems in the world? So it's like, I don't know, maybe you intervene and you're like, the car stopped too long at the stop sign. Or another person might say, I wanted to go faster. Or another person might say the car isn't aggressive enough. There's a lot of ways of describing that exact situation where the car just like sits there for a couple of seconds at the stop sign. So that range, it's like, oh, okay, so people could describe the exact same event 10 different ways. That's helpful to Tesla. You're right. Yeah. And especially when we get Optimus in environments that there's, because it's manipulating objects, there's so many more possibilities. So this is a really good, wow, I hadn't thought. You're probably right. They're probably just storing all of those voice messages take like zero space, right? They're just kilobytes. So they're tiny. So they can just pile this stuff up even if they're not actively using it, and just
I think that they may already be training. They may already be training on it at a small scale.
Right.
Just so okay, I want to come back to there's the training compute and there's the inference compute. So for those who don't understand what I'm talking about, as I understand it, you have all these GPUs at the home office and they're doing auto labeling and they're processing all these video clips and figuring out this stuff. But what they're ultimately doing is they're changing the weights that the chip in the car uses. What happens is the car sees a bunch of photons, a bunch of, the light comes in the cameras, it all goes into the car processes all that information and somehow comes out with driving inputs, with driving outputs, steer this way, accelerate this way, whatever. And the car isn't doing auto labeling itself. As I understand it, what's happened is they've done all this training at the home office and they've sent instructions down to the chip in your car. This is how you're going to react to all these situations. And am I correct in my interpretation of what's going on, that there's this chip in the car that really just takes photons in and applies its training to what it's doing, rather than the higher level thinking of figuring out the training level stuff?
Yeah. So okay, so starting with the training stuff, there's a whole different, I think I talked about that earlier, but there's a whole different thing that does labeling, that looks at the world, that says, if somebody intervenes and they look at the video, it's like, what happened here? And it can actually pull that in and it can retrain things. So that's a whole thing over here. The actual inference model is based upon a model that they train on site. So that, let's just to give it an arbitrary size, let's say that the big gigantic neural network inference model that Tesla has in-house is like 100 gigabytes. It's like, that's how big the model is. Now it's probably way bigger. I mean, it's probably smaller than that, but just for whatever. But when you get to the car only has 10 gigabytes of memory in it. So it can't contain that entire thing. So what happens is they train a model that's got a lot more like different things. It's got dropout layers. It's got all sorts of like high precision numbers and all of these other things. And there's a process called distilling when they take, so they have the training module, that's all separate, that's all done separately. Then they train the inference module or the inference network, and that thing is a certain size. And then they squish that down to a small enough size that it actually works in the car. So there's many, many steps to get down to what you actually drive with in the car. And one of the big steps, I think, is they lower the precision of the numbers. So when you're training, you want your floating point number, that weight, to be like 0.751275. It's like this huge long number, because you care about training and adjusting all those things. When it comes to actually running in the vehicle, you might be able to get away with like 2 or 3 digits. And Tesla actually invented a whole new numbering system for computers where they have I'm forgetting the name right now, but it's just 8-bit integer. It's just tiny. It's a really, really, really small number. But what they can do is 8-bit floating point, and they can manipulate the mantissa and anyway, that doesn't matter, but they've got these ways of squishing these models down into something that will run on your car.
Okay. So I want to look forward to what appears to be happening now, which is a transition from hardware 3 to hardware 4.
Right.
And there's two major changes. One is the cameras in hardware 4 are higher resolution. And what I think is the bigger change is the chip in hardware 4 has more processing speed, more memory, whatever it I don't know exactly what the difference. I know Green the Only has done has provided some information on it.
Right.
So when you just described this point of distilling the larger model into something that the chip can handle, is part of the theory that the more advanced chip in hardware 4, you have to do less distillation. It's able to handle it's going to be a more faithful application of the larger model because it has more memory and more processing speed.
Yeah. And I think that's definitely part of it. The other part is, well, there's 2 other parts. Number one, the full self-driving chips have 144 teraflops in them, the hardware 3 that we're all driving, most of us are driving. Hardware 4 has a lot more than that, although I don't know if anybody knows exactly what that number is. But the really big thing is that hardware 3 is memory bottlenecked. So earlier in this conversation, we talked about how you have to fit all of that stuff. You have to transfer all of these things from memory into the chip and then output them from there. The output part is easy because that's a decision that it makes, but the input part, it's bottlenecked. It can't really fit these gigantic models and all the data at once. And so they're having to do a lot of very clever tricks to kind of work around that to get it to work. One of the biggest changes with hardware 4 is it's got I'm going to get these numbers wrong, but I think there's 128 lanes of memory in hardware 3, but they're only like 32-bit, or I'm going to get this wrong. But anyways, effectively, there's 256 lanes and they're bigger. So it's about 4x the amount of memory that can be shoved into the chip at the same time. And that, I guess, is the reason why you can't backwards compatible hardware 4 into hardware 3, because the power requirements and the memory requirements are substantially bigger than hardware 3. But anyway, that's so essentially what they're doing is they're making this memory bottleneck less so that they can shove more data through it at the same time. So it processes faster.
At the same time, as you've got bigger, your cameras have higher resolution, so you're actually squeezing
exactly
in.
Exactly. So it's able to handle that more data. It doesn't have to distill these things down quite as small. It's able to push all of that through faster, and it's able to operate on that quicker. So, it's basic hardware improvement. It's the kind of stuff that we see all the time, but it's very specific to what Tesla's use case is in this case.
Now, I had somebody saying to me the other day that the hardware 3 cameras were not enough to be able to achieve full self-driving. And I just think this is wrong. I think I've looked at the camera output, on my screen. It seems to me it's a pretty good representation. If you said we're 320 by 240 8-bit grayscale, or not, sorry, 16 levels of gray, like I'd say, yeah, that's probably not enough to perceive the world. But if you have 720p and 65,000 colors or whatever, I don't know what the color depth is. Yeah, that's a pretty good representation of the world. I'm not convinced that having higher resolution cameras adds that much value. What are your thoughts on that?
I think it does under certain circumstances. So, and I think what'll happen with hardware 3 is that it will drive you, but it will only do it when it's decent weather outside, when it's not pitch black. There will be places where it'll just be like, I'm not going to do it right now, which is fine. Most of the time you drive, it's sunny or a little bit cloudy or maybe a light rain or something, right? So there's it will drive under most circumstances, but not all. But under those weird circumstances, hardware 4 with the better cameras will do better. But I think the really easy way to look at this is when you back up in your Tesla and it pops up the video. I only look at the video now. I glance around to make sure nobody's walking, but it's perfectly usable. I, as a human being, can look at that video output and utilize that entirely for backing up. I don't have to look around behind me anymore to see what's back there. And I think that tells you all you need to know. And you've got 8 of those cameras, and every single one of those is producing that quality output. So under most circumstances, it's going to be totally fine to drive.
I will say that my impression is that with the raw photon counts in particular, that even in low light conditions and awkward conditions, I think the cameras still see better than humans see. Yes. Even if they don't see as well as hardware 4 sees, if they see as well as human. Right. And then this turns to another question, is that people who have hardware 4 cars, FSD beta is not active yet. And my theory on that is they don't have enough data yet to train the hardware 4 cars, because the hardware 4 cars are looking at a different data set. They're getting much higher amount of video in. So it's going to take time to generate enough data. So are they unable to run the hardware 3 training on hardware 4? Do you have any thoughts on whether they have to completely retrain the models for hardware 4?
I have a feeling that their goal will be to run it in a bit of a simulation for a while. So what they might do is they might take the camera input and kind of reduce it to effectively what the old cameras were, and then run the old models. So probably the first thing they'll do is, honestly, you won't see a benefit of hardware 4, because any increased speed will be made up for the fact that it's running a simulator. It's it's pretending to be hardware 3. And so that will be, again, this is just me guessing, but that would be the number one thing. And so people will be like, hardware 4 is not any better than hardware 3. And it will be like, well, yeah, because it's basically pretending to be hardware 3 right now. But then what will happen, as you're saying, is that as they get more data, as they get more information, they can begin to put pieces in that are hardware 4 specific. And so maybe a year from now, something like that, we'll start to see some substantial increases, and people will go like, whoa, this drives way better than hardware 3. But right now, you're not seeing any evidence of that. And I didn't realize. So you know that for a fact that people who have hardware 4 are not able to purchase FSD beta right now? You can't just buy it?
That FSD beta is not. I've seen people say I have
Wow.
a hardware 4 car and FSD beta is not active yet. And
Wow.
I
That's
think that
interesting.
makes sense that, FSD beta, the current cars, the hardware 3 cars have been running on 720p cameras
Right.
and a set of training optimized for the chip in our car. If
Right.
you have a new set of cameras and a chip that's optimized differently, they need to get enough cars out there to generate enough vision data, enough visual data. And then you have to have the compute cluster have enough compute to be able to run separate models for hardware 4. And it probably
Right.
doesn't make sense to spin up those models until you have 50,000 cars on the road,
Right.
generating enough data.
Right.
And right now, as I understand it, Model S and X and Y are shipping, or at least some of Model Y are shipping with hardware 4.
Right.
I don't think Model 3 is shipping with hardware 4 yet. I don't know that.
Right.
I think the first reports were S and X, and then later some versions of Model Y were shipping with hardware 4.
Yeah.
And
And we're going to see this whole thing, no matter whether people are driving with full self-driving beta when the Cybertruck comes out or not on hardware 4. But the Cybertruck is so much different in shape than the other vehicles that they've had that it's going to have a whole. So I 99% guarantee that FSD beta is not going to be available on the Cybertruck for the people who buy it, on the first day. Those people are going to be a little disappointed because it's going to take 6 months or something probably before it's able to use full self-driving beta.
I actually I think at one point Elon mentioned that hardware 5. I think hardware 5 is coming, and I think the next generation vehicle will run hardware 5, which is going to be maybe the same cameras, because I don't know if you need to go more than 4K on your camera.
Yeah, there's a limit to how much camera you need. Yeah.
But if hardware 5 is going to be 3 times as fast as hardware 4, and I think Green the Only said that hardware 4 actually uses more power than hardware.
Yes, it does. That's the reason why it's not backwards compatible. But it has to do with the memory lanes. They use so much power to Yeah. So sorry, I wasn't specific about that, but that's exactly why you can't just fit a hardware 4 chip into a current Tesla.
Right. So Elon seems to think, and I think Elon tends to be over optimistic, that we're going to go to this version 12 foundational model with end-to-end neural nets, and that this is what's not going to be beta. What do you think he meant when he said it won't be beta?
That's really provocative. It seems massively optimistic to me, given the fact that we still have so many weird little problems and stuff. So number one is he knows way more than we do, because he's of course looking at the alpha builds and the pre-alpha builds. So that is something. But also number two, he is super optimistic about things. But it sounds to me like what he's saying is that version 12, once they get this end-to-end thing and potentially have this foundation model that they do, which will be a huge architectural change, that he's predicting that that's going to be good enough that it won't have to be considered beta anymore. I don't know. I don't believe that means he's expecting regulatory approval to let people sit in the back seat yet, but that he would be saying that this is better. I think in his mind, the idea of level 3 autonomy and having it be ready and not beta is that it would be one standard deviation above average. So that puts it somewhere around 67%. So if you imagine all of the drivers, so we have our terrible 10% that we talked about earlier, and you have the bell curve, and you have everybody who's hanging out in the middle, and then you have that long tail of people at the top end who are race car drivers or something, right? Who's excellent drivers. It'll be somewhere in that top, one or two standard deviations above the middle. So once it's that good, I think he'll be yeah, this is out of beta because it's better than most drivers. That would be my guess, is that's approximately when he would call it.
So I tend to avoid the Society of Automotive Engineers level 2, 3, 4, 5 distinction.
Right.
And the way I look at it is there's going to come a moment where Tesla says, you have to sit in the driver's seat, but we're not going to nag you anymore.
Yes.
That you can look at your phone, you can look away. You have to be in the driver's seat, and you have to be ready to take over if the car tells you need to take over.
Right.
That to me, that's the level that, if you get to that level, that's a game changer in terms of value to the driver. If I can look at my phone while we're driving, because it's annoying. Honestly, it's annoying to me if I get a text message and
Right.
I'm in a situation where I'm on an empty road where
Right.
I'm not going to be making any turns anytime soon. There's not a lot of traffic. Then I feel if I make the decision, I'm comfortable looking at a text message at this moment, I actually disengage self-driving.
Right.
I can look at my phone without the car nagging me. So getting to the point where, and I think that's less safe than the car
Oh,
driving.
absolutely. It's less safe. Yeah.
So I would rather the car kept driving, not nag me, and I'll look at the text and I'll keep paying attention, and I know how to do that. You know, have some
Right.
faith in me, boy. But I think we're going to get to the point where we get to that level, and then it won't be long after we get to that level till they say, okay, you can ride in the back seat, or you can just step out of the car and let the car drive away. That
Right.
the jump from we don't need to nag you anymore to you don't even need to be in the car anymore is not going to be that great. And I
Right.
don't know what, and I think the problem with level 4 and level 5, the distinction, as I understand, is level 4 can drive without human supervision in certain locations, and level 5 can drive in
It's certain
anywhere.
locations and certain weather conditions.
Right, where level
So
5 is like all conditions, and I don't think that's necessarily the way I worry about it.
no.
So anyway, I think that's coming.
I'll just say, like, from the SAE levels, level 5 is unimportant because who cares if it can't drive in a blizzard on a country road that's not marked? That's such a weird case that it's like, fine, who cares if it can't drive in that situation? Level 3 and level 4 or whatever equivalent. But I agree with you. I think that whether you want to call this level 3 or whatever you want to call it, but the idea that it would give you at least, you have to sit in the driver's seat, but it will give you at least 10 seconds of warning to pay attention. So you're like taking a nap and all of a sudden it's like, wake up, but it's not like you have to take over. Currently, it's like you have to take over now. When it says take over, you're like, it's now. It's like within a second. And so if it can increase that envelope to 10 or 15 or 20 seconds, and it's like something bad's coming up, don't really know, please wake up, pay attention, and now take over. If it can just give you 10, 15, 20 seconds of warning, then that is a game changer, because then you can pick up your phone. You can take a nap. You can close your eyes. Good God. How many road trips have you been on in your life where you're just going like this? You're like, trying desperately to like pry your eyes open. It's like, gosh, it would be great to close your eyes for just like a minute on a trip like that. So that's the kind of thing where it will be a huge safety and convenience advantage when we get to that point.
Yeah. All right. So the one thing I want to talk to you, the one thing on my mind that I want to cover before we wrap up, one of the biggest flaws that I see in my current operation of FSD beta is, I would say, mapping and navigation. That,
okay. Yes.
In particular, the maps aren't perfect. There's a particular spot that I frequently, that it will take me to where there's a no, it thinks it's going to make a left turn onto a main road, but there's a no left turn sign at that spot. And I disengage and I make a left turn the street before and come out a different way where I can make a left turn. So it has a lot of mapping errors that are built into the database that it should. So what we have is we have 4 million cars that are observing the road. And when they see something that doesn't fit with what the map told them would be there, the cars should be uploading that to the cloud.
Right.
And I envision a world where Tesla creates its own crowdsourced mapping that's near real-time or near real-time updates, so that you're driving your car down the road and a Tesla somewhere sees, wait a minute, they just blocked off a lane, right? All the cars in the area are notified, hey, this lane was blocked off. It doesn't have to be all the cars in the world would be notified of a change in the map, but you can see where any car within a mile of that location would be notified, or any car that's got a path that's going through that would be notified, hey, there'd been this map change. And that could be real time or near real time. And maybe you'd need 2 cars to confirm it. But I haven't seen any indication that Tesla is doing anything to do crowdsourced maps. What are your thoughts about the potential for using the cars to create crowdsourced maps, not from humans crowdsourcing the information,
but from the cars.
Information.
So number one, of course, Tesla is using Google Maps, because you can see that down in the corner. It says data provided by Google Maps. So that's currently what they're using. And Google Maps is not perfect, as you're saying. Sometimes it just has mistakes. And I think that leads to a lot of the problems that we see. Because I'll even see, like, if it does those weird lane changes, you'll literally see like the navigation path shows that it's like changing lanes. So maybe the dude who was driving the Google car around changed lanes at that point, and so your car like is like, oh, this is the, but anyway, it's a very kludgy situation at this point. currently what Tesla does, and Greenly only did find this, was they have like hints on the map. So it'll be like, oh, by the way, there's a stop sign here, or oh, by the way, there's a pothole here. So it will put in notes on the Google Maps that will tell things. So it's a step towards doing its own mapping solution. But I think that what Tesla's working on right now with their reconstruction of scenes and all of these things, if they're not working on their own mapping solution, I don't know what the hell they're doing, right? It would be idiotic for them not to be working on their own. Now, I don't know what their terms of agreement with Google Maps are. Like if they said that we're going to do it for a decade and we're not allowed to use any other mapping solution, but under the hood, whatever that expiration date is, they have to be going like on the next day, we want to have our own map solution.
Right.
Because I think I agree with you. And I think a lot of people have that same experience. The biggest problem with full self-driving right now is the integration of that navigation data with the driving. If it is in the correct lane and has the right information, it drives really, really well. But half the time it's like suddenly changing lanes and then having to get over 2 lanes because it has to make a right-hand turn. And it's like, what the hell? There's just bad data, and it's not able to drive as effectively as it should. And so I would be dumbfounded if Tesla's not working on their own mapping solution at this point.
Yeah, I think as far as the lane change behavior goes, that is, they went to a large language model approach to understanding lanes. And they're still training it.
Right.
They haven't had that many iterations yet. They need more iterations to get that trained better, and it's going to take time.
And Ashok said that it's a very complicated problem because roads, your picture's back behind you, excuse me, behind you, those roads go on. They're not just like the car itself is like a little blob in space, but these roads are just like, it just goes and goes and goes. And it becomes very complicated for a representation of that internally to the computer. Again, very different from how humans think. Like we look at a road and we're like, there's the road. It just goes on. That's a road. But the car doesn't think that way. It has to map out every little piece of that. And that's really computationally difficult.
I think on the one hand, it could make the cars drive better if Tesla crowdsourced maps in that way. On the other hand, I think Tesla could end up having a better mapping product for everyone.
Yeah.
Like they could basically displace Google Maps. By the way, I don't believe they're only limited to Google Maps. I've been told they also use Open Street Maps or something like that.
Oh, yeah. I think that's just for parking lots, though.
And there was
I don't know.
There was a celebrated incident recently where Ross Gerber and Dan O'Dowd went through this one intersection where the car didn't recognize the stop sign or not quickly enough. And one of my friends went and checked on Open Street Maps or whatever and said the stop sign isn't there, and he put it in. And it started handling it better the next day.
Right.
And so is it that Tesla did something to fix the handling of that sign, or did my friend adding the stop sign to the Open Street Maps solve the problem? I don't know. But it seems to me that it would make a lot of sense to just crowdsource that data. And it doesn't have to be HD maps. It just has to be, hey, I noticed a pothole here. Hey, I noticed there's a new stop sign. There's some cones here. A lot of different things that can be material changes. And over time, the cars can recognize which data needs to be uploaded and which doesn't. And that can, change behavior.
Right.
So,
but I'll take this one step further because this is Tesla and they would do something like this. Everybody has created sort of a bird's eye level. That's what maps have been, right? Since TomTom and all those guys in the early days, they just have a top-down view of the world, and they can put things on it and all that. But Tesla has a 3D view of the world, so they could create some sort of hybrid 2D, 3D map where it doesn't just have like a basic, looking down at the car driving, but it might be like, there's a literal pothole. I can see the 3-dimensional outlines of this. How deep is this thing? I can literally see the cone there, not just the fact that there is construction, but where the cones are. And so they could do a step change better map than any other thing. And as you say, maybe that's the kind of thing that they could sell that or a dumbed down version to other companies. So eventually Google might become a customer of theirs where they're like, here, we'll sell you our data that you can make your maps better or something. But I think that I don't see Tesla just replicating it. Why would they do that? That's like 25-year-old technology. That's like a way of looking at the world that's old. Why not make it better as long as they're redoing it? So that would be, again, my guess.
And people don't realize this, but one of Elon's first startups was Zip2, which was online mapping.
Right. Yeah, exactly.
Before PayPal. All right, so I'm out of material. I think we've covered a lot. We've gone almost not quite 2 hours yet, but we've gone more than an hour and a half, I think. And I want to thank you. Is there anything else on your mind as you're looking at the future of FSD and Optimus that we haven't covered that you're excited about at this moment?
I think what I'm most excited about is AI Day 3. Like whenever they announce it, I've heard from reasonably trustworthy sources that it's going to happen. So, just
So
fingers crossed that we'll be there. Fingers crossed that it'll happen. But that's what excites me the most. I'm sort of waiting to get confirmation on some of this speculation at this point. Hopefully that will happen this fall. And then that and whenever version 12 or like apparently 11.420 is something they're waiting for, that's going to be a big release too. So so anyway, there's some big releases coming out soon, so that's what excites me right now. But I think we've covered quite a bit of what's going on, the state of the art right at the moment.
yeah, AI Day 3, there were 2 previous AI days, and they're basically events where Tesla engineers present, here's some of the things that we're working on to improve FSD or to improve Optimus, and maybe other things that they're working on. And it's really a recruiting event where they're trying to motivate people who are interested in AI programming to come work for Tesla. We're doing really cool stuff here. Yeah.
Yep.
It's not as much for investors or nerds like you and me to like watch this and say, oh, that's cool. It's really to lure in people, like to get the best quality people to apply to work there so they can get really good quality. Because one of the things that's driving Tesla's success is they get really good engineers working there.
Right.
Okay.
Yeah, the team is small, but the team is incredibly talented and they can do amazing stuff. Yeah.
All right. Well, so thank you, John, for coming on my channel, and I'll send me links to what I need to link in the description below.
Yeah.
Everybody, please check out John's channel, Dr. Know-It-All, on YouTube. I'll put a link in the description below. Check out his merch, support him on Patreon. Check out my t-shirts at elonbits.com. And the stainless steel, very popular stainless steel water bottle. The Tesla Man t-shirt is the most popular.
Nice stainless steel mug here, Cybertruck. So like I said, get your Cybertruck early. So yeah, but definitely the 2 videos about Ashok and Phil's talks are definitely worth watching if people want to dive into this stuff in even more detail, excruciating detail. So yeah.
Okay, so thanks everybody for watching. John, thank you again for coming on.
Sure.
We'll talk again soon. And best wishes to you and your family as well.
Thank you so much.